Yeah, so we were happy to sponsor DevOps Talks because it's a really good opportunity to meet with practitioners, people who are actually in the field doing the DevOps work, if you will. And we really liked the format, having a single track format where, the talks are all very high quality, and they're all relate back to the central DevOps concepts, the things that people want to hear about. And they've all been really excellent talks. So Chef has kind of been around since the early days of DevOps. Our founders, one of them was one of the architects for EC2. That was kind of a cloud thing back at the beginning. One of them was the director of operations for EC2. So the operations, the development, those were there. But also Adam Jacob, our original founder, the author of Chef, he ran a practice helping companies automate. And so Chef has been there on the DevOps scene since the early days. And a lot of the big names in the space, we work with them. They worked at Chef at times. Jez Humble worked for Chef for a while. Nicole Forsgren, John Willis actually hired me to Chef. So it's always been kind of right in the middle of things, and infrastructure as code has always been part of that. And so Chef has grown up with DevOps. There have been a lot of really great talks, a lot of really good conversations on the hall. I really enjoyed this morning's talk from Elizabeth from CyberArk, DevOps and security together. The talks yesterday were all very good. And I'm especially looking forward to the closing keynote from Sidney Dekker. He's kind of a big name in the space, and I'm always glad to get a chance to hear him.
Peter has had an extensive career working in IT. He's led teams across large enterprise solutions with a focus on web and AWS cloud technologies. His specialties include backend architecture, microservices, and orchestration of systems. Peter also holds a PhD in computer science from Monash Uni. So please put your hands together and welcome Peter to the stage.
Thank you. All right. Hello, everybody. Wow, these are bright lights. That's awesome. I saw that awesome prop, and I was thinking, how can I use it? I haven't got a way to use it yet, but I'll think of something. Hello, everybody. Good to see all of you. I was here on this stage. I guess it was the other stage, one over there, last year, and I gave a presentation called Serverless, the future of software architecture. And when our organizers invited me back, I thought, okay, how can I what can I talk about this year? What can I say that's interesting? And so I thought, okay, I'll kind of reflect back on my talk from last year and tell you about our experience. Where was I right? Where was I wrong? Was I wrong the whole way? Maybe, who knows? Anyway, so I think this will be an interesting talk for you. I think it will be interesting for you if you are looking at serverless, if you are using serverless, but I would love to hear your feedback. What do you think? Was this useful to you? So a little bit about me. I started as VP of Engineering at A Cloud Guru. Right now, my role is VP of Content, so I kind of commission and find awesome new content for our platform. I'm an author of this awesome book called Serverless Architectures on AWS. It's been recently translated to Japanese. So if you can read Japanese, let me know if it's good. And I am also the organizer of Serverless Conf. It's like an awesome community grassroots conference on serverless technologies. And it kind of reminds me of this conference, which is why I love DevOps Talks so much. So a little bit about us. We teach cloud computing to the world, right? So our company, A Cloud Guru, we create awesome courses that help to skill up developers, solution architects, network engineers, security engineers, get you better at cloud computing, right? We have kind of been focused on AWS for the past 2 years, but now we're branching into Azure and GCP and containers and Linux and all that cool stuff. So quick shout out if you have ever thought about kind of teaching people, making courses. We are looking for full-time and freelance instructors. So yeah, if you're interested, please come and talk to me after this presentation. So the thing about our platform is that we've been serverless from the very start. So we started, it was a greenfield platform, and we thought, okay, we're going to go all serverless, not a single server anywhere. Interesting, awesome. And it's been quite a crazy but fascinating experience. We have 500,000 users of our platform, so it's not a small thing. It's not like a trivial toy, implementation. It's actually quite a big scalable platform. We've developed actually a bunch of courses because we kind of fell in love with this whole serverless notion, and we ran our conference. And I just want to say, look, I'm not a zealot. It worked for us, but it may not work for you. So I think you need to kind of explore your requirements and figure out if going serverless is the right way to go. It probably is. So what is serverless? For us, it's basically about running code in a compute environment like Lambda, so like a function as a service. That's weird. It's about using various backend services, right? It's about using things like DynamoDB. It's about using SNS, SQS, S3. It could be about using other non-AWS services. We use Algolia, we use Firebase, we use Auth0, we use various Google services. So we do make this heavy use, we have this heavy use of managed services throughout our platform. And it's about certain patterns and architectures, applying them as well. So this is kind of like a little table. I'm actually working on a new book. I don't even know why. It's a fun experience working on a book. It's a lot of work. And kind of this is a table that I took from there, that compares serverless to infrastructure or platform as a service offerings. And, you can kind of see that, serverless is all about, using functions. It's about kind of focusing on architecture and patterns rather than, low-level infrastructure like servers. So this is our platform, right? I had a look at our stats from February, and this is what I found. In February, we did 49.9 million invocations of Lambda, right? So nearly 50 million. I was really hoping for the 50 number, but that's what it was. So maybe in March, we'll cross 50 million. You can see that at any given time, we're kind of running 73,000 Lambda functions in any given hour. Sometimes we're getting to 116,000 executions of a Lambda function per hour. So those are our peaks. In terms of API requests, so we use API Gateway, which is a managed API service in AWS. We put through, I guess I'd say 27 million invocations or requests through that API Gateway in February. So we have a few endpoints. The big one is our BFF service. Does not stand for Best Friends Forever. It stands for backend for frontends, and it's basically our GraphQL endpoint. And I'll talk a little bit about that in a second. So 27 million API requests. It's kind of cool. We store 2.5 terabytes of data in S3 buckets, right? We create video courses. They can be quite lengthy. We store various versions, 1080p, 720p, 480p, HLS, WebM, etc. So we have a lot of data. And on average, each day, we serve about 1.3 terabytes of data. So this is to all of our students around the world. So you can go sign up, watch a video course. It's awesome. It's fun. 1.3 terabytes. So I had a look at our bill. Does anybody want to take a guess how much the bill was for the month of February, given the stats that I just highlighted, and given our 500,000 users? How much? 100,000. Excellent guess. So I can tell you, it's between $0 and $1 million. Does that help? 100,000. Do I have any other takers? 900,000. 1,000. All right, that's a lot of guesses. All right, great. They're all wrong. I'm sorry. So this was the bill. And that kind of shocked me as well. It's a little bit crazy. So first of all, API Gateway. People say that it's super expensive, and it actually isn't. It was only $100. Lambda was $206 for that many invocations, which is kind of cool. We use DynamoDB. That's our database, source of truth, $400. Redshift, that's our data warehouse. So we store a lot of data there as well. CloudFront, so that's kind of our bandwidth cost, right? That's all the data that we send out to our students. Those are the video courses going out. So that's $3,700. By the way, this is US as well. Just should mention it. I'm sorry. heard the disappointing groan here. So I'm sorry. But if you take out CloudFront, if you take out the bandwidth cost, like honestly, the whole infrastructure cost is insanely little. It's quite awesome. So anyway, that's something that I wanted to share with you. If you look at our kind of architecture, we started with a monolith, and then we broke it up into various microservices, just like Ben mentioned before. And that has worked very, very well for us. So we have an API gateway, we have a GraphQL endpoint, and then we have a bunch of microservices that perform various functions. And that GraphQL endpoint can talk to these microservices. So sometimes a microservice is fronted by a Lambda function, sometimes it's fronted by another API gateway, and we do some GraphQL schema stitching to make everything work. It's interesting that kind of our legacy, we used Firebase when we initially launched the platform. So Firebase is a real-time streaming database developed by Google, and it kind of powers the front end of our website, right? It's like a materialized view of the data that we want to present. And so we have this interesting thing where DynamoDB is our source of truth that has all the data, but then run triggers of DynamoDB tables that go and update Firebase, and then Firebase basically pushes updates to our UI. So we have this real-time kind of update of our user interface. This is kind of like a CQRS-lite approach. We have Algolia, which allows us to search for things really quickly. It's an awesome service. Check it out if you haven't seen it before. And of course, we have CloudFront and S3, and our $3,000 bill comes from there. So that's a big kind of like a high-level view of our architecture. Now, this is what you all came to see. DevOps pipeline, CI and CD. Look, we have a very simple, I think, straightforward continuous integration, continuous development workflow. Our source code is stored in GitHub. We use Travis CI. It runs a bunch of tests against our code using Cypress, Jester. We used to use Selenium before. We swapped it out for Cypress. And then once everything's fine, we can deploy functions to AWS, update various other services, deploy our front end to Netlify. So we don't use S3, by the way, for our front end. We have an SPA, and we don't use S3, and I'll talk about why in just a minute. And then possibly we update other services like Firebase and Algolia as well. We use Serverless framework, which I encourage you to check out if you're going to get into Serverless, if you're going to be kind of deploying things. And we use Ansible to spin up some kind of like local environments for our developers. So a few stories for you. And I would love for you to give me some feedback after I finish, whether you thought this were interesting and useful to you, so that I could make this presentation a little bit better. So first one, front-end and API failover. This is awesome stuff. So back in December, our website went down. Very naughty. We pride ourselves on having awesome uptime for all of our students. So website goes down. It's no good. We use Netlify, right? As I said before, we use Netlify as our static hosting platform. And we use Netlify rather than S3 because Netlify allows us to pre-render our website, and that was very useful for crawlers, right? Because we have a very JavaScript-heavy website. Back in the day, Google's crawlers weren't very good. Well, actually, Google was fine, but there were other bots that didn't crawl JavaScript very well. So we use Netlify to pre-render our content and host our website. So Netlify goes down, right? It happens, unfortunately, but we go down as well. So I started thinking, how can we prevent this occurrence from happening, right? What can you do? So this is one way you could potentially solve this issue. You can have your primary website in something like Netlify, and then you can have a second, like a backup copy, the same thing in an S3 bucket, for example. Then you could use Route 53, which is Amazon's DNS service, and you can make it fall over from Netlify to an S3 bucket if there is a problem. And it turned out to be super simple to do. And I'll show you like in 5 awesome screenshots. I'll show you how to do it, and you'll be experts at the end of this, hopefully. So what we do is we create a health check in Route 53 to ping our website in Netlify. And if we get an error message code, like if you get a 500 or a 404 or something like that, and if you get it, say, 3 times in a row, we know that something has gone wrong. And so we can then immediately update our DNS to point to our S3 bucket instead of kind of pointing to Netlify. We don't want this. So here we go. So here's a sample website deployed to Netlify. This is how it looks. We have the same website deployed to an S3 bucket. They are completely identical single-page applications with Angular and React, actually both. This is what Route 53 looks like. And as you can see, I have this H5 boilerplate health check. It looks at a specific URL that I've given it. There's a request interval of 10 seconds. So every 10 seconds, it will check the website. And failure threshold of 3. So if there are 3 failures in a row, if it gets 3 500s in a row, it will declare that the endpoint is unhealthy. And awesomely, I can also check health from different regions. So I can kind of hit our website from all over the world. So those are the health checker regions. So then I go to set up a record set. The first one is an A record. Here I'm pointing to our Netlify distribution. It's fine, nothing fancy. I do say that I have a routing policy called failover. And I also set this as kind of a primary distribution set or record set. And then I have a secondary one, right? This one is pointing to my S3 bucket, which is fronted by CloudFront. So in other words, if a health check determines that something has gone wrong, if we're not returning a 200, then we will switch over to our CloudFront distribution instead. Oh, yeah. So I was going to actually use some of our developers and just get them to make a thumbs up, but I ran out of time, so I had to go with this smiley guy. So this is normal operation. I go to the website. I hit it. As you can see, it's all obviously using HTTPS. And we can see that the response is coming from Netlify. Everything's fine. Then I go and I delete the website in Netlify, because that's how we roll. So you can now see that the endpoint, the health check, is saying, whoa, 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 unhealthy. Something has gone wrong. We're getting back a 404, so that's bad. So that happened within 10 seconds, which is the threshold that I've set. But luckily, it automatically updates DNS to point to this new S3 bucket. So I go back to refresh my page, and I'm now getting my website from S3. That's it. So that's how easy it is to set something up like this. So please give it a shot. Try it in your spare time. It's actually just so much fun to do. So that was cool. But what about APIs? That sounds awesome, but sounds much more complicated. Well, you can actually do something similar, possibly. So here we have 2 APIs. One is deployed to US East 1, which is in Virginia. The other one is deployed to US West 1, which is in California. So completely different regions, far away from one another. Takes like 8 hours to fly from one to another or something like that. And they are completely identical. So they are identical systems with an API gateway with Lambda functions. I'm also using DynamoDB global tables. So global tables, it's a new feature announced by Amazon, and it's basically a way to replicate your data between different regions, and DynamoDB does it for you. So you create a global table, and then your data is automatically replicated between various regions. So it's a very kind of powerful thing. It does cost a little more, but it's worth it. But we can have the same system, right? We can have a health check against a particular region, and if something goes wrong, we can immediately switch to another region. Now, can I just say that, yes, this does become much more complex once you add messaging and queuing and other things, because you might have things in flight, messages being processed, and then you switch to another region, and yeah, so things can happen. But in general, this can work very well. So this is what you can set up in an API gateway. You can define 2 regional endpoints. You get your own target domain name, your own URL for each region that you have. So I have both of them there. So one is US East 1, the other one is US West 1. I create a health check, same thing for an API. It pings the US East region every 30 seconds, but again, you can configure this. We can check where we're getting our responses from, and we're getting them from Virginia. So this is US East 1. That's awesome. then I can go into the API gateway and I can stuff something up, right? Instead of having no authorization because I trust everyone, I'm going to enable IAM-based authentication. So this will force our API gateway to return the 403, right? So that's the code that we're getting back. So our health check knows that something has gone wrong. It's not a 200. Something is misbehaving. And we immediately switch to the other region, to the other system that we deployed, to US West 1. So it's kind of cool, and it can be seamless, and your downtime can be very limited and automated, and that's awesome. So that was part one. Making functions and services more resilient. If you were here last time and saw my presentation, I showed off this beautiful little picture. So this is an example of one of our pipelines, right? We do a lot of transcoding, so we allow our lecturers, our instructors to create a video, upload that video straight from a browser to an S3 bucket, and that kicks off this pipeline, this process, where we take the video, we give it to a service called Elastic Transcoder. Elastic Transcoder creates a bunch of other versions of that video, so like 720p, 1080p versions, HLS, WebM, I mentioned all of this before. Then it pushes those new versions into another S3 bucket that automatically kicks off, pushes a message into an SNS topic, which spawns off a whole bunch of other functions, updates our database, etc. And this is all event-driven, so there's no kind of input from me as a developer. It's all event-driven. Everything propagates automatically. So the one problem that we had with this is, what do you do about failures? What happens when a Lambda function fails? How do you know? How do you detect it? How do you replay a message? What do you do? If I can go to the next slide. Luckily, Amazon announced support for Deadletter queues, which have turned out to be super useful for us. The basic idea is, if your Lambda function fails, you can tell your Lambda function to push that message that it failed to process into a different SNS topic or a different SQS queue. And then you can hang like a Lambda function of that SNS topic, in our case. You can't do it off a queue, unfortunately, at this stage. But if it's an SNS topic, you can hang a Lambda function, which can then go and email you, or maybe you can resubmit the job again, or do something else with it. But at least now we have this kind of automated way of detecting when something has failed and hasn't been correctly processed by Lambda. We kind of used to do this all manually, and it was a lot of work. But now this works a lot better. The other problem is destroying your relational database. So we all know that Lambda can scale like crazy, right? And it does. And if you unleash Lambda against your old little relational database, it will destroy it, right? You will run out of connections. Your connection pool will be saturated. What are we going to do? Nothing. So it's going to be a bad situation. And this can happen. Luckily, you can now set a concurrency limit on each function. So you can say, I don't want to have more than 200 invocations of this particular function, right? Or maybe 10 invocations, or maybe 20, whatever kind of number you desire. And so this really helps to control kind of that spawn of Lambda functions. There is one other thing. There's something that we call serverless cancer. And this happens when you have, let's say you put a file into an S3 bucket, which invokes a function, and then that function, say it creates two new files and places them in that same S3 bucket. And that causes two functions to pop up, and that creates 4 files, and it just grows, right? And it's like, then you have 4 functions, 8 functions, 16 functions, and it just basically, it runs until your AWS bill comes out a lot. So that is not good. Don't do that. So you can set a reserved concurrency. So you can control. You can say no more than 20 invocations of this particular function ever. There have been other solutions. So this is one solution proposed by Amazon. It's a little bit complex. It's kind of, basically what they're trying to do here, they have the system where they try to control the connection pool So they try to count kind of how many open connections they have at any given moment, so that things can be a little bit more dynamic rather than just setting 20 invocations as a hard limit on a Lambda function. So I think it just shows that we are still yet to solve this, and I'm sure Amazon is working on this as well, but it's still a little bit tricky to get right. So just don't forget about this if you're dealing especially with a relational database. If it's DynamoDB, no problem. Unleash the Lambda, it's fine. So just some other tips from me. One function, one task. Don't try to build fat monoliths or routing functions or something like that. Just try to stay lean, if possible. Don't forget, there's no state in a function. That's why we can actually create those awesome environments in different regions and route people to one environment and to another environment, because there is no state. It's all stateless. It's awesome. Design for failure. Things will fail, so use things like DLQs to capture failures. More memory equals more CPU and I/O. If you allocate more memory to a Lambda function, you'll also get more CPU, and that's great, right? Your Lambda function will run faster in terms of compute. You can set function concurrency to 0 as a kill switch. So if you do end up creating that serverless cancer where your Lambda functions are just exploding, quickly log into your AWS console, set 0 as the concurrency limit, hit save, and you're fine. Or delete the function. Keep permissions and roles tight. People forget this. They think that security is not a problem anymore with serverless. No, that is not correct. So please keep your kind of permission structure, your roles, as tight as possible for your Lambda functions. And look, incremental architecture, it's not dirty. You can forget everything that I've said, to be honest. Just build your first Lambda function, make it a monolith, get it working, see how it works, and then you can continuously refine and revise and make it better. So don't be afraid of that. I'm running out of time, so I'll be quick. I wanted to kind of briefly talk to you about some patterns and architectures. And I would love to have your feedback after, whether you have found this useful and what kinds of other patterns and architectures you would like to hear about. Because we are producing these courses and books. So getting your feedback and knowing what you want to see is key to us producing the right content. So these are some of the possible architectures that you can build using serverless or really any kind of architectural approach. You have your primitives, you have your APIs, orchestration, traditional patterns, your workflows, and then you have what we call, I'd say, compound patterns, right? They are kind of architectures which take those other more primitive patterns together to produce a working system. So you have your backends for web applications or mobile applications. You have your CQRS type systems, data processing, etc. So let's take one, API proxy. I love this little pattern, so easy to implement and really saves you bacon when you need it. It basically acts as a mediator between two systems that cannot communicate directly, right? And it's an awesome little pattern. It allows you to transform request and response payloads between two completely incompatible systems. So let's say you have two legacy systems, right? One is using JSON, right, a legacy system. Another one uses XML. How do you get them to talk to one another? Now, you can try to modify one of them or both of them, couple them together, make them talk to one another. Or you can introduce this layer, this API proxy, with an API gateway and a Lambda function to transform requests and responses between the two systems. So now they are decoupled. They don't know about this layer in the middle, but they can talk to one another. So I've seen this system in practice. I've seen people implement it, and it's awesome. It works very well. Everybody is probably familiar with the fan-out pattern. It's basically, you can kind of send a copy of your packet or message or whatever you want, your data, to multiple endpoints, and you do it usually asynchronously. So it's actually kind of funny that we started writing about. So in our new book, we started writing about fan-out, but it turns out that there's asynchronous fan-out, there is synchronous fan-out, there's transactional fan-out, and they have different semantics depending on what you are trying to achieve, right? This is a basic asynchronous type of fan-out. I mean, it's the same as having basically a for loop and just invoking different endpoints asynchronously. Here I'm using an SNS topic, which asynchronously can invoke a whole bunch of Lambda functions when you need to. A challenge for you, how would you design a transactional fan-out? It's possible, it's doable. Please come and see me after this if you have a solution. And finally, a third pattern. I honestly didn't know how many patterns to present to you, so I just came up with 3. This is an inline stream transform pattern. So this is about having streams, right, and pushing data into a stream and then processing that data. So here, I should say very powerful because you can have your consumers and producers work at a different rate. So your producers can work faster, your consumers can work slower, and you can multiplex or demultiplex at the source or destination. So here's what it looks like, right? So you can have a producer pushing data onto a stream. Here's something interesting. There's a transformation function. So this is something built into Firehose, built into Kinesis Firehose. There's this function that you can attach to a stream, which will transform your data. I mean, it's your function, so you can make it do whatever you want, but it can transform your data as data enters the stream, right? So you can filter, you can process, you can do whatever you want, and then it leaves data in the stream for other consumers, for other functions, or whatever consumer you want to have to consume. So that didn't come out very well. But the cool idea is that you have this transformation function which kind of sits atop your stream, transforms your data, and then your other consumers can kind of consume the data off the stream when they need to. So this is what I wanted to say. They are not 2 different streams. It's the same stream, and that's just a special function that sits on top of it. You could potentially build the same thing with 2 streams. You can do it, but it's kind of up to you. I should say that a stream can be sharded, so you can have multiple shards. But if order is important, if the ordering of the messages coming in is important, do not shard, obviously, right? You have to have 1 shard. If you don't care about ordering, then you can shard to your HUD's content. It will cost more, but make things faster as well. Look, how do you get started on this stuff? It's very exciting. It's very interesting. There's kind of a lot of innovation happening in this serverless space. A lot of great new projects, patents, architectures coming out. You can check out serverlessconf.io and check out videos on YouTube. So you'll see lots of great presentations about serverless, about patents, architectures, and what people are building at the moment. All very useful stuff. Please check out our website. We blog a lot about serverless. We have some of the most awesome thought leaders blog and create content for us. There's this awesome book that I came across. And also, please follow us on Twitter as well. I think that's it from me, and we can go to lunch. How cool is that? Yeah.
Thank you.